So first question is MVVM, model view view model. Okay, what is MVVM? So it is architectural pattern for iOS Swift programming language. So for Swift, when you're writing a Swift code, you should keep in mind which architectural pattern I'm using, whether it is MVC or MVVM. So the most recommended one is MVVM, and I'll tell you why. So MVC as it says, model view controller is the full form. So what happens over here is view model view controller. View is the view part, the UI layer, which is being confronted to our, like, which is being operated by our user, right? So view sends the event to the controller. So controller is the one who takes care of all the events. So on the view, when someone press on hit, like enter button is clicked, so on that, what kind of event is happening, so that is sent to the controller, and then controller send the request to the model. So model is what model is something which is projecting our database, the data of our database. Okay, and it performs business logic if required, and then the model notifies to the controller. And then in case if there is any data changes, the controller sends data to the view. Okay, so it is like view sends data to controller takes it, sees if there is any logic not required, it sends it to model sees it, okay, this is the data from database, mappings and all, everything will happen over there, and then it will come back to controller will see the data, okay, I have received the data, now if there is any business logic, I'll perform on it, any data processing I'll do over here, and then it send it back to the view. Okay, so this is our model view controller. Now, the problem is with this model, our view controller used to be very, very massive. So all the data logic, business logic, and data processing, everything used to happen in view controller. Okay, so that's why it was very, very massive. And that, so to make our view controller a little easier, to be a little bit more easier on our view controller, we go with MVVM, model view view model. Okay, so what happened in MVVM is we combine the view controller and view part together and make it a one part. So view controller and view is combined together, and now it has become one part, which is called view. Okay, and then we have one more layer added, and that layer is called view model, and this new layer will communicate with our model class. The model class, which is representing the database, is, so view model will be communicating with the model class. The view model will be responsible for all the data processing, or to perform any kind of business logic. All the things will be done in view model. So what's the result of that would be our view controller would be much lighter now. It will be less heavy. There won't be much heavy code, so it will be easier to understand, and it will be good structure, right? So the same thing as MVC over in MVVM, we have model view view model. Okay, so view would be presented by view controller, and view model would be the one who would be taking care of the all the business logic and data processing, and model would be the one which will be presenting the data from our database. Okay, example of that is, for, let's say, for a student class, our student view controller will act as view to display the final result on the screen. So it is like UI part of that. Okay, and then view model would perform heavy task, like the business logic and everything would be done in the view model, and then our student model would be the one which will perform, I mean, which would be the one our, like, representing the data. Okay, so that is our view model. Dynamic dispatch. Okay, dynamic dispatch is very complex, not complex. Okay, it is a simple topic, but it is like behind the scene, it's kind of complex. I'm very confused with that, so I'll try my best to explain. Okay, so dynamic dispatch is the process of selecting which implementation of polymorphic operation to call at runtime. So we all know polymorphisms, right? So polymorphism means that in the base class and in the subclass we have a method which is of the same name, and at the runtime it so at the runtime only our compiler will understand that okay, this is the method we have to call. So if it is in the same class, the compiler will understand okay, this is the method we need to call. But if it is in different calls, then compiler may get confused, right, that whether I have to call the base class method or do I have to call the subclass method, right? So this is what is dynamic dispatch. And for example, if a base class overrides a method of its superclass, dynamic dispatch figures out which implementation of the method needs to be invoked, okay, and that of the whether it would be the base class method or it would be the subclass method. Okay, so dynamic dispatch is the one which decide which method to invoke from either from base class or subclass, because the method name is same in both the classes. Okay, so how do we do it, how do we achieve it? By using a keyword called dynamic. So with the keyword dynamic, if we say in the base class, in the subclass, if we say okay, this function and this is dynamic, in front of that function if we say dynamic, then our compiler will understand okay, I cannot take this, I can't do it, it has to be decided at the runtime. So at runtime, dynamic dispatch will decide that which method needs to be called. Okay, so Swift provides two ways to achieve this dynamism. This is what they call it, dynamism. Table dispatch and message dispatch. Okay, so table dispatch, what is table dispatch? So with this method, a class is associated with a table which is called a virtual table, which comprises of an array of functions pointer to the real implementation corresponding to that class. So it will be like array of the pointers, like pointers and the functions, right? So it is like a table which will tell us that okay, with this, for this function, for this call I should call this function. So virtual table is something which will tell us that which function to call in Swift. This is one way of doing it. Another way is message display. Message display is Objective-C's way, right? It is not Swift ways, it's Objective-C that provides this mechanism. Okay, and every time an Objective-C method is called, the invocation is passed to objc underscore msg send, which handles the lookup. So this is also a lookup, and there's something called objc message send something, which decides whether which method to call. So it is internal things. So just know that in Swift there are two ways to perform dynamic dispatch. One is table dispatch, one is message dispatch. And what is dynamic dispatch is dynamic dispatch is figuring out which function to call at runtime. That's all. I mean, yeah, that should be enough. Okay, what is dynamic dispatch versus static dispatch? Okay, this was also asked in one interview. So when something is dynamically dispatched, which means that if compiler does not know which method is being called at runtime and has to figure it out, then it is dynamic dispatch. So the reason would be you are overriding the method of the base class, and that is one of the scenario when compiler would not know. That is the only scenario actually when compiler will not know that which function I should call at the at compile time, and that's why it would be decided at at runtime with the help of dynamic dispatch. So when the compiler doesn't know which method to call at compile time, that is when we use dynamic dispatch. Okay, and static dispatch is when compiler knows, totally opposite, right? When compiler knows that okay, this is the method I need to call at compile time, then it is static dispatch. And there are few ways to do it 100%, like okay, assure it that this is static dispatch by making the class as final. So means if you mark a class as final, nobody can subclass of class. So it means that okay, this is the only class and it cannot be inherited. There's no way of inheritance or anything in that. So whatever function is there in that class would be called directly. Another example is static keywords for keyword for when defining type methods or properties. So this keyword is really just short for final class actually. So this lets the compiler know that this is the final implementation of the method and it will not be overridden. So if it is not being overridden, it means it can be dispatched statically. Statically dispatched means it can be called at, like it can be figured out at which method to call at compile time. Whereas dynamic dispatch means we cannot figure out that which method we should, like compiler will not be able to figure out which method to call at compile time, and that is why it would be called as dynamic dispatch and it would be decided at runtime. Next topic, closure. So what are closure? It's been asked a lot in interviews. So closure are self-contained blocks of functionality that can be passed around and used in your code. So just like closure is like block of code without any name. So it is a headless function which doesn't have any name. You don't even use func keyword. So in Swift, when you're creating a function, you use func keyword, right? But it is a function which does not need any func keyword or any, any name of the function. So it's a headless function. Okay, so the syntax would look like this. So in the curly braces, you will write parameter and then return type. In is the keyword, and so let's say like over var say hello equals to, in the curly braces you'll say, in the parameter you say name colon string and then return type string, and in you will return hello. So it is a variable which is returning the name using closure. So this is how you write the closure. And there's another way of writing closure. It is passing it inside the function. So you'll do it like this. So the same thing, this is a variable. Over here it's a function. So say func say hello, and inside the function so we have two parameters. One is name string, which is a normal parameter, and another one is the closure parameter. It's a function parameter, function without head or func keyword, which is called closure, right? So closure string and then return type void and then our curly braces, and in that I can call this closure function like with this name closure hello, and then I can return the name. So this is how you write it inside the function. Okay, this is very good. Escaping and non-escaping. People ask this question a lot, and it is very, very important. If you're going for iOS interview for senior software engineer or lead, you will be asked this question 100%. Maybe if they forget it, they don't know it probably, but this is very, very good question, and it is 100%. If you answer this question, they'll think that, okay, this person knows something. So let's talk about it. So closure, so we have closure, right? So we pass closure as argument in the function. So what happens is when the closure is invoked after the return statement, that's when we call it the closure is escaping. So okay, maybe confusing, right? So when you write @escaping in your closure definition for the function is when you want your closure to live like the closure should live even after the return statement. So even after the return statement is called, your closure will be called after the return statement also. So let's say it is useful when you're calling making a network call, right? You're doing a REST call, and so it takes time. The REST call will take time, right? So during that time the return statement will be called, and then if you do not write @escaping, your completion handler, the closure completion handler will not be called. But you need the data, you need the completion handler data, right? You need completion handler to persist, that parameter to persist throughout the function even if the return is called. So that's why you will be calling escaping the return statement. So when you say escaping, it means you are escaping the return statement, and your closure completion handler will persist even after the return statement. Okay, so in Swift 1 and 2, closure parameter was escaping by default, but and if you want if you want your closer not to escape the function return statement, then you will have to externally write at the non-escaping. Whereas in Swift 3, it is now non-escaping by default. So they have, interchanged it. So now in Swift 3 onwards, non-escaping is by default, and escaping you have to write it externally. Like you have to write it now if you want your parameter to, live through live even after the return statement. So why did they do it, why Apple did it, is the reason is that not the most beneficial reason is the performance. The reason why they did it is mainly for performance and code optimization. So if they do non-escaping by default, then compiler knows that the closer is non-escaping and will take care about the memory allocation for the closer. So that's why. So for performance and code optimization, Apple made it non-escaping by default. Okay, because if it is non-escaping, it means that the ARC will take care of the memory allocation for the closer. If it is, so this is the reason why they did it. Okay, so I hope you understood, right? Escaping means escaping the return statement, right? Like your closer parameter will live even after return statement. Understand it, remember it. Okay, what is lazy? So a lazy stored property is a property whose initial value is not calculated until the first time it is used. You indicate a lazy stored property by writing lazy modifier before its declaration. So whenever you say lazy, it means that that particular property will not be initialized until it is being called object or something like that. So the initialization will not happen. It will only be initialized when something some other reference is being called by some other reference. So when it is very important, it is important in a very complex project or anywhere. Whenever you want to write optimized like good code, you should be using lazy a lot, so that you don't run into memory leak issues. So if your app is a complex one, then memory issues are one of the major challenge. Okay, so the developer should be really writing an optimized code to consider memory allocation at first place. So if your app is complex, then you should be writing optimized code which take care of the memory allocation. So in that case, you should be so the developer need to avoid doing expensive work unless it's really needed. So and that is what you can use with lazy, right? You don't want to initialize something if it is not needed. So you will write in lazy keyword in front of that, so that whenever it is needed, then only it will be initialized. Okay, and there are some rules, like you cannot use lazy with let. Okay, and you can't use it with computed properties, because a computed property returns the value every time we try to access it after executing the code inside the computation block. And that is why you should never ever use it with computed properties. You cannot use it with let, and you can only use lazy with member of struct and classes. So you can use lazy with the member of struct and classes, and lazy variables are not initialized automatically, and so it is not thread safe. So lazy is not thread safe. Okay, guys. So there is a there's a drawback, but it's good. Like you need, if you worry about your memory allocation, memory of your project, you should use lazy, and you shouldn't be initializing anything if it is not needed. So yep. Okay, unowned self and unowned week. So what is an unowned self and unowned week? So the only time where you really want to use unowned self or unowned week is when you would create a strong reference cycle. So if you don't know what is strong reference cycle or retain cycle, I discussed it in my first part of the interview questions. So go for that. I will discuss it here also in a little brief way. So, a strong reference cycle is when there is a loop of ownership where objects end up owning each other. So, it's like a cycle of ownership, maybe through a third party, okay? And therefore, they will never be deallocated because they are both ensuring that each other stick around. So, strong reference cycle is like when everything is referencing to each other with strong reference, and nothing can be deallocated because it has some reference counters, retained counters more than 0, right? So you cannot deallocate it. So in case of closure, you just need to realize that any variable that is referenced inside of it, so any variable which is referenced inside of the closure gets owned by the closure, okay? Any variable which is inside the closure is owned by the closure, and as long as the closure is around, those objects are guaranteed, I can't say it, guaranteed to be around. So any variable which is inside closure is owned by the closure, and as long as the closure is around, the object is guaranteed to be around. The only way to stop the ownership is to use unowned self or unowned weak. So do you get it? So closure is like, so we just explain what is closure, right? So anything, inside the block of the closure, whatever variable you will be defining or using, defining, it will be owned by the closure, okay? And it will stick around as long as the closure is there. And the only way to stop this ownership, only way to remove this deadlock is by using unowned self or unowned weak, okay? So if the class owns the closure and that closure captures a strong reference to that class, then you have a strong reference cycle between the closure and the class. And this also includes if the class owns something that owns the closure. Okay, that is very confusing. But okay, yeah, so closure is like, it creates strong reference cycle because anything which is inside the closure is, it will stick around as long as the closure is, and it creates a strong reference cycle. It creates a strong reference with the class, okay? So because of these strong references created by closure, there is a retained cycle created, and that is why you have to use unowned self or unowned weak. So when do you use unowned self and when do you use unowned weak is if if self could be nil in the closure, use weak self. So weak can be nil, but unowned cannot be null. This is also we talked in our last interview questions series, right? The first part. So unowned cannot be null. So whenever you are using unowned, you have to make sure that that particular object can never be null, whereas weak can be null. It can be an optional. So over here we are doing it for our class, right? So self is representing to the class, and class will never be null. Okay, so in this scenario we can use unowned self. Okay, so this is why in the closure we so it, like, mostly we use unowned self. We can use weak self also when the self can be nil. So this is what unowned self and unowned weak, unowned self and weak self, unowned self. Okay, process and threads. Okay, this is not very much related to Swift, but I was asked this questions in one of the interview, and I thought I'll put it in the slides because I don't know, I mean, they wanted to check the basics, so I guess they had this question as well. So what is process? A process can contain multiple threads of execution, and each thread can perform multiple tasks at one time. So what is task? Task is a simple single piece of work that needs to be done. So task is a simple piece of work which needs to be done. Thread, a mechanism provided by operating system that allow multiple set of instructions to operate at the same time within the single application. So as we all know, thread is for multi-threading. When you want to do a lot of tasks at one time, you will use thread, right? So if you want to perform a lot of tasks at one time in the back, so you'll put it in the background thread and it will keep happening. So we have used thread, so we know that. Process is an executable chunk of code which can be made up of multiple threads. So what is process? Process is lot of threads. So combine lot of threads, and that is process. So what is task? Task is a piece of work, okay, which needs to be done. Task is a piece of work, like task is a task. It's very simple, as the word says. Thread is like multiple tasks doing at one time. So thread is like doing a lot of tasks at one time is thread. And then process. So process is something which contains multiple threads. So combination of multi-thread is process. Cool. So thread, a lot of tasks doing at one time is thread, task, simple piece of work. Process, lot of threads. So execution of a lot of threads is process. So that is process and threads. It's like very basic, and sometimes they ask it, so just know it. Okay, operation and GCD. So in Swift, Objective-C, how do we achieve multi-threading? So this is Apple's way of achieving multi-threading for us. They provide us two libraries, which is GCD and Operation. GCD is the base library, the most lowest library which we have, which Apple provides. So what it says is GCD is a lightweight way to represent unit of work that are going to be executed concurrently. So you don't schedule these unit of work. The system takes care of scheduling it for you, and adding dependency among blocks can be a headache. So yeah, canceling or suspending a block creates extra work for you as a developer. So GCD Grand Central Dispatch is an Apple's way of handling multi-threading, as I said, and it is the lowest library which is provided by Apple, but it does not come with many operations. Like you cannot handle the operations very well as you can do in the operation library, right? So you cannot cancel a task, you cannot suspend a block of code, or you cannot resume it. So you can do it, but you'll have to write a lot of code. So yeah, so it is like the basic level of the library which Apple provides for multi-threading. Then operation is also for the same purpose, but it is like one layer above GCD. So this is higher level library to perform multi-threading, and it comes up with a lot of features, like you can handle dependencies, you can reuse the operation, you can cancel the operations, you can suspend the operations, you can resume the operations. These kind of features are there, which is provided by Apple. So yeah, and OperationQueue are built on top of GCD, and as a very general rule, Apple recommend using highest level of abstraction, then dropping down to the lower level. So Apple's recommendation would tell you that you should use Operation and OperationQueues instead of GCD, because GCD you will have to write a lot of code, but with Operation and OperationQueue, like the same thing can be done in a very systematic way. So yep. Operation. Okay, let's talk about operation in more details. So when you say operation, as we said, it is for multi-threading, and what you have to do is, operation is similar to task. We just talk about task, right? So it represent a specific task, and to implement operation, you will have to write a abstract class. So what you have to do is write a class which is subclassing the operation library provided by Apple. So this is how you implement operation in Swift, right? So operation is like abstract class which represents a specific task, and to perform operation, you have to write operation, like you have to subclass your class with operation. and you will have to write a main function. So main is the function which is provided in operation class. So if you are subclassing operation, then you will have to subclass, like you'll have to write something in main class, and that is what will be the executed at first, right? So this is where you perform your task. Main is the function where you perform your task. So over here we have an example, class image downloader, which is extending operation class, and then we have photo record, and we are initializing the photo record, and then in main function we are calling some URL to get data of that, to get data and then process that data. So you're doing multi-threading in the main function. Okay, operation queue, right? So operation is a particular task. How do you perform it? How do you execute it? So that is where comes operation queue. So a queue that regulates the execution of operations. So when you have to execute your operations, you will have to put it in a queue, and then that queue will execute all your operations. Okay, so an operation queue executes its queued operation objects based on their priority and readiness, and after being added to an operation queue, an operation remains in its queue until it reports that it has finished its task. So until the task is finished, it will stay in the operation queue. And as you know, you can suspend all the operation, as we said, right? You can suspend, you can resume, you can finish all the tasks at once. You can set some limit also on your operation queue, like you can say max concurrent operation count would be 4, so number of operation for that particular operation queue would be 4. So it is based on, so if you specify it as 4, then the number of operation which will run on your operation queue will be 4. But if you don't specify it, it will automatically compute it based on your device. So if you're running your operation queue on a very good device, then it will take a lot of operations and perform a lot of operation at once. But if you do it on like low device, then it might take some less number of operations. So yep, that's device specific. And over here we can see the example, like let queue operation queue, and in the queue we can add operations like queue.add operation, and then we are adding these operations. So yeah, so that's operation and operation queue. This is how you perform multi-threading using operation. You write your task using like subclassing from the operation, and then you queue those operation in using operation queue, and execute those operations and execute those tasks. So task operation is the same thing. Okay, next question is GCD. So as we said, GCD is the lower level library and to perform concurrent operations. And how do we do it? We do it using DispatchQueue. So DispatchQueue, it comes with two types of queue. One is global queue and one is main queue. Global queue is the one which does the background task, which is non-UI task, and main queue is the one which does the UI specific task. Okay, and also you can specify priority also. Like you can say that my queue, in my queue, what is the priority of my queue. So there are multiple, like there are like one priority. One is like user interactive, user initiated, default, utility, background, unspecified. So mostly I have used background one. So if you want to do some tasks, so over here we have example. So DispatchQueue.global. So as I said, global queue is the one which you will use if you want to perform any background task. So global queue.global, and then QoS is the quality of service, where you can you can tell that which type of priority I want. So over here I want background, so I want it to run in the background, and then async, so it will run asynchronously, and then you can write whatever background task you wanted to perform. And then dispatchqueue.main.async. In this block, you will be writing all the UI updates. So whatever you want to do once this operation is done, whatever UI update you want to do, you can write in dispatchqueue.main.async. Next is dispatch group. It is being asked a lot. People think it's a very important topic, and it is. So let's say you have got several long running tasks to perform, right? And after all of them has finished, you'd like to run some further logic. So only when all of those tasks have finished, then and only you can perform some logic, okay? And you could run each task in sequential fashion, but that isn't so efficient, right? So sequential fashion means that you run the first task. Once that is finished, then you run the second task. Then that is finished, then you run the third task, and then when that is finished, then you write your logic. But that is like a very very long task, and it will take a lot of time, right? So honestly, so this is what dispatch group allows you to do. You can perform a lot of tasks at once, and when once all of them are finished, then you can do some logic which is based on those tasks. You cannot perform that logic before completing those tasks. So example is, you need to run two distinct network calls, and only after they both have returned do you can do some necessary parsing of that response. So once you have the response from both the network calls, then only you can do the parsing, and that is why, and this is where you can use dispatch group. Another example is, let's say an animation is running and parallelly you have a long database call, and once both of them is finished, then only you would like to hide the loading spinner. So there's a loading spinner you need to hide, but you can do it when that animation is, there is one animation which is running, that animation is finished, and you how do you do it? Using dispatch group. So you do it like you know initialize the dispatch group. So let dispatch group equal dispatch group, and then you enter into this dispatch group. Dispatch group dot enter is the function, and then you perform your long running function. And inside the function, after writing all your operations, you can write dispatch group dot leave, and then for another function, for another task, you can, before running the task, you can say dispatch group dot enter, and then long running function 2, and inside that function also you can write dispatch group dot leave. And once both of these functions have finished running, then you will come into this block, which is dispatch group dot notify queue.main. So this will only be executed when once both of these long running tasks has finished. Those when you have long running tasks and you have to perform something, once all of those tasks are finished, then you go for dispatch group. And how to do it: you enter the dispatch group, you leave the dispatch group, then you enter the dispatch, you leave the dispatch group, and when you leave the dispatch group, you will be notified. Like when both of these long running functions are finished, then you'll be notified. So there's a function called notify in dispatch script dot notify. This will be called only when these functions, like these tasks, are done. Okay, codable and decodable in Swift. Okay, so this came in Swift 4. Before that, why do we use it? So remember, we had JSON serialization, and then once you have the JSON, you have to parse it. So remember the JSON parsing in Objective-C, and before Swift 4, you have to write a lot of code. You have to write a lot, like you have to map the data to your model class, which was very difficult, right? So what does codable and decodable does? It does this JSON parse. It makes this JSON parsing very very easy for us. So Codable protocol is new protocol introduced by Apple in Swift 4, which can provide encodable and decodable built-in feature, and it will make JSON parsing easier. So to make JSON parsing easier, now we have a codable protocol. So how do we do it? So let's say we have this JSON, user ID1, title, completed this JSON, and then what you'll do, you'll have to write a struct, okay, which will be confirming the protocol Codable. So this is the protocol, right? So let's say struct name user, and we will inherit the Codable protocol, and then you will have to write the variables exactly matching to the the variable name should be matching with the name what you have in your JSON. So user ID, ID. So it should be matching, okay? And then once you have the struct, you can use this like, I'm tired. Okay, and we can parse the JSON like this. So and so JSON code decoder is the function, and with the decoder you can decoder or decode user. You can, so user is the decodable function, decodable struct, and then form data response. Okay, so this is like 2 lines of code, right? Remember how much line of code we had to write without decodable? And I mean, I love this functionality. I really adore it. I'm thanking to Apple to introduce this functionality. I really like it. It's just 1 line of code. You can parse your JSON data in just 1 line, and I love it. Over here we can see a complex JSON. It is a very complex JSON. Let's see. So we have like JSON which is like status is success status, and then in the document we have another and then, so as you can see, it's a very complex JSON, right? So how do we use decodable to decode this? How do we use Codable to decode this JSON? So to write this, you have to write struct response Codable, and then status code, and document. So document is another part itself, right? So you would create another struct for that, for document, okay, and then that struct will be referenced over here. So over here, so this is this is how we do it. And then again, a profile is another part, so we'll create a different struct for it, and then that would be defined inside over here. So when you're creating profile, so the same rule goes here. The variable names should be same to what you have, should be matching to what you have in your JSON. And then for if it is if it is what do you call this, like nested, if it is nested, the nested part, you should write a different struct itself. So you'll write a different, so document is nested JSON, right? So you should write a different struct for that, and then use that struct to reference this document in this first struct. So this is how we do it. And then while in your function, while decoding, the same thing, you will use JSON decoder dot decode, and in this two functions, two parameters you have to pass. So the response.json, so I had created the main struct name was response, so I'll just use this. These will not be used because it is like internally used, right? We are referencing it internally. So response.self, and then from JSON data, and then we'll get the response, we'll get the whole response. So do you remember how much line of code we had to write for this kind of nested JSON? It was very, very difficult. So yeah, Codable has made it very, very easy. So I love it. I adore it, and you should also love it. You should use it. And this is being asked a lot these days in the interviews.